Inverse functions are functions that reverse or undo another function. To write the inverse function, we use often the following notation. So f to the negative 1 at x, or sometimes we just say f to the negative 1. And so in even more simplistic terms, what we say is that the x and y, or the independent and dependent variables, switch roles or functions. We could just say switch roles within the function. And so by that, there's a couple of ways that we can solve for these. The first way is with the table of values. Now, if we have a table of values for f at x, which reads the following values for x, and then the following values for y, to write the values of f at negative 1 at x, then all we have to do is just switch the values for each of them. And so the table of values for this function would just be simply the x's and y's switch. So where x was 0 and y was 3, now x is 3 and y is 0. And where x was 1 and y was 2, now x is 2 and y is 1. And we have the new completed table of values for our inverse function. So if we're going to solve for an inverse function algebraically, here's the steps that we need to abide by. The first thing is you're going to do is swap all the x and y values. Once you do that, then you're going to isolate for y, and then whatever the equation of y equals, you're going to rewrite that into f to the negative 1 notation. So using these steps, let's determine the inverse function f to the negative 1 at x for f at x is equal to negative 2, 3x plus 5. So the first thing we're going to do is, if I rewrite this as y, instead of f at x, I'm going to write it as y equals negative 2 over 3x plus 5. Now what I'm going to do is I'm going to switch these out, and that's going to give me x equals negative 2 over 3y plus 5. Now what I'm going to do, so that would be step 1 done. Now step 2, I'm going to isolate for y. And we're going to speed this video up here, do some algebra. So we've isolated for y, and again, I showed some of the steps over here, but you could pause the video and try to isolate for this one on your own. And we have y is equal to negative 3 over 2x. So what we could say is that f to the negative 1 at x is actually equal to the y that we just solved for. And this would be the inverse function of this function over here. So is the inverse of a relation always a function? And in general, the answer would be no. Now, the way that we can actually understand if something is, or predict, I should say, if an inverse of a relation is going to be a function, is the horizontal line test. Now, to determine if a relation is a function, we use a vertical line test. But in this case, it's going to be a horizontal line. And the way it works is this. You take a function, for example, let's say we draw on our x and y plane here. And let's say we have a function that looks like this. So I'll make it like a circle. Okay, now, whatever produced this graph, it wouldn't be a function, because if I did the vertical line test, I could see that it hits more than 1 point, so it's not a function. Now, if it is a function, if we inverse it, then we're going to do the horizontal line test here. So the way the horizontal line test works is that if a horizontal line is put through and the line intersects 2 or more times, so in this case, if I look at this function here, it intersects here and here, then the inverse, right, so f to the negative 1 is not a function. So in this case, f to the negative 1 would be not a function because it intersects twice, and that's enough to make it not a function. Now, let's say we have something else. So let's say I draw at the bottom here another graph where we have f at x, which is drawn like this. Okay, or this is a relation. So this here is not a function. So I'm going to write not a function because we can see that it fails the vertical line test in the sense that it intersects twice with the function. But if I do the horizontal line test, so let's say I take a horizontal line and I put it through and it only goes through once. This means that the f to the negative 1 of the relation, right, or the inverse of the relation is a function. So horizontal lines are done for the inverse functions and vertical lines are done for the parent functions.